Our math adventure continues. We're working with proportions today. Remember, a proportion is just an equation where one ratio is set equal to another ratio. Now, proportions by definition means that they have to be the same in lowest terms for the ratios. Well, we can see 3 to 4 is in lowest terms, but 9 to 12 is not. So if I take and I reduce 9 to 12 by dividing both the top and the bottom by the same number, I'm getting an equivalent ratio. And so 9 divided by 3 is 3, 12 divided by 3 is 4. If they're the same in lowest terms, then I know those have to be proportional. But there's also a second way that we can do this, and that's called cross products. And what I'm going to do is I'm going to multiply the diagonals together. And if the diagonals equal the same number, I know I have a proportion. If they do not, then those two ratios cannot be proportional to each other, which means they can't be the same in lowest terms. So if I go back to my original, and I take and I multiply 4 times 9, I get 36. And if I take then the other diagonal and I get 3 times 12, notice I also get 36. I didn't even have to reduce this second ratio in order to see if it was proportional. All I could have done is done this quick check by multiplying those diagonals, and because the two answers are the same, they have to be proportional. And this is usually how I go about checking for proportions. Very rarely do I reduce to lowest terms for that. Now, we know that sometimes we're giving an unknown and we're trying to find a ratio that would be proportional to another ratio. So an example of this would be 5 is to 12 as x is to 36. Now my job, I have to make sure that these become equivalent ratios. So sometimes the math is really easy, and all I have to do is take a look at the numbers that are given. Now I don't have enough information for the top because I'm missing this number, but I can take a look at 12 and 36 and I think, what relationship do the two of them have? Well, I know that if I multiply 12 times 3, that equals 36. And if I do 5 times 3, because you have to keep it balanced, I get 15. If I reduce 15, 36 to lowest terms, then I know that those are proportional. And if I divide both of these by 3, I get 5 12s. I know they're proportional. Now I wouldn't do the quick check on this because 12 times 15 is a really large number and 36 times 5 is a really large number. So in this instance, I'd probably just do the checking by seeing if I can reduce them to lowest terms and that they're the same thing. Now, sometimes it's impossible to use equivalent ratios because when I take a look at this one, I know x is to 9 as 4 is to 6. Well, I'm taking a look at 9 and 6 and I don't see a relationship between the two of them. I can't think, what would I multiply or divide these numbers by to get the other? There's nothing I can see. So what I'm going to do is I'm going to come back to this cross product method. And what you can do is you can set up that cross product. So I'm going to go and multiply 9 times 4 and I know I get 36. And then I'm going to multiply x times 6 and I get 6x. Now this just simply set up an equation for me, and it's an easy equation. It's a one-step equation. So I know I need to get x by itself, but it has this times 6. So how do I get rid of times 6? I divide by 6. But if I do it on one side, I have to do it on the other because we have to keep the balance. This tells me what that answer needs to be for x. So it tells me that this has to be 6 is to 9 as 4 is to 6. And remember, in lowest terms, everything should be the same amount. So if I divide both of these by 3, I get 2 to 3. And if I divide both of these by 2, I get 2 to 3. And I know because they're the same, they have to be proportional. Now, sometimes they're going to build on it and they're going to make it look a little bit more complicated. But we still use the concept of cross products. Now, once we start to get to these more complicated ones, we really can't use equivalent ratios anymore. So we have to go to this cross products. So once again, I'm going to take a look and I'm going to build an equation. And I'm going to do 54 times 18 is equal to 36 times x plus 5. Right there, I start to see that distributive property, and I have to solve distributive property. And so I'm going to do that first, and remember, it's 36 groups of x plus 5. Therefore, I'm going to take 36 times the first, so that's 36 times x. Bring down that addition sign, that never changes, and then I'm going to do 36 times 5. So in reality, I'm just building an equation. Now my numbers are going to get pretty large here. When I do 54 times 18, I get 972. 36 times x is 36x. And 36 times 5 is 180. Now I just have a two-step equation that I need to solve. So I'm going to start on the side that has the variable, and I need to get rid of this plus 180. So I'm going to use inverse operations to do that. So I'm going to subtract 180, but the second I subtracted it, I went out of balance. So in order to pull myself back into balance, I have to do the same thing to the other side. So I'm going to subtract 180 there. Well, this side is easy. I'm just left with my 36x. 972 minus 180 is 792. Now I use inverse operations to get x by itself. So this is 36 times x. So I'm going to divide by 36, and I get 22, equals x. So I know here, this number here would be 22 plus 5, therefore it's got to be 18 is to 27, as 36 is to 54. We can get more and more complicated as we go. We'll just build on the math that we've always used before, but this is just working with the proportions using cross products, which is my favorite method. So are you up for the challenge? Time to get to work.